Here we have a toboggan and a child which together weigh 40 kilograms, so the weight is 40 g newtons, and they are on a slope, and you're told that they are accelerating down the slope at 1.2 meters per second per second. So what we're going to do is use Newton's second law down the slope to work out what the frictional force is. Now, because the toboggan and the child are moving down the slope, the frictional force must act against that. So there's our frictional force. So Newton's second law then says that F is equal to ma. Be careful with the F though, that means the resultant force acting down the slope in the direction of the acceleration. And there are two forces tending to make it move up or down the slope. Acting down the slope, so we'll take that to be a positive direction, we have the component of the weight, in other words 40 g cos 80 degrees. Acting against that is the frictional force, and that's equal to the mass, toboggan and child together, which is 40 times A, and A is 1.2. So if we want to work out what F is just going to be this, F is going to be the 40 g cos 80 minus the 40 times 1.2, and that comes out as 20.1 newtons. Okay, we're now told that the toboggan and the child are being towed up the slope using a rope, and the rope is acting parallel to the slope, and it's the tension in the rope which is the force pulling the child up. Now we're told that the frictional force is the same as it was earlier. We've just worked it out. It came out as 20.1. It was actually, in your calculator memory, 20.07 newtons. You should save that so that it's accurate. Okay, so what we're trying to find, constant speed, in other words acceleration, is equal to 0, which means that the forces acting up will equal the forces acting down. Acting up the slope is just the tension in the rope. Acting against that is the frictional force, so that's the 20.07, and also the component of the weight, which is acting in a downward direction, because that's tending to oppose the motion up the slope. In other words, the 40 g cos 80 degrees. And if you work out that, it comes out as 88.14. In other words, the tension in the rope is 88.1 newtons.